In this third section, we're going to start by looking at quadratic equations and their graphs. To find the equation of a quadratic graph after a translation PQ, we just need to replace x by x minus p and y by y minus q in the original expression. We show this in example 1. The graph shown is a translation of the graph y equals 3x squared. We need to find its equation in the form y equals ax squared plus bx plus c. We're going to start by considering the vertex of the graph, this point here right at the bottom. We can see that it's at the point 2 minus 1. In a quadratic graph that hasn't been translated, the vertex will be at the origin. So we can now see that this graph has been translated by the vector 2 minus 1. So if we replace x by x minus 2 and we replace y by y minus 1, or in fact y plus 1, we can get the new equation. So y equals 3x squared becomes y plus 1 equals 3 x minus 2 all squared. But this is in the wrong form. We need to rearrange this. Taking the 1 over to the right hand side, opening up the brackets, getting rid of the brackets and collecting terms gives us the final answer of our graph. Our second point is that quadratic expressions can always be written in the completed square form, as shown here. We'll go through an example in example 2. First, we write out the expression. We're going to factor out the minus 2 from the front of the x squared. So now we're dealing with only an x squared term at the beginning. We now write the inner brackets for the x squared, and to complete the number that goes after the x, we have to half whatever's in front of the x in the expression. So in this case we get minus 4. Now if we expanded this squared bracket, we would have x squared, which we want. We would have minus 8x, which we want, but we would also have 16 from the minus 4 times minus 4, which we don't want. So we have to take that minus 16 away, and then finally we have the 10 from the line above. We can collect these two constants together and we can multiply out the outer brackets to get our final answer. Here is a typical exam question for you to try. Press pause, and once you have finished doing it, press play again to see the answers. Let's start with part A. We need to express this in complete square form. So the expression, we can start with the bracket squared. We're going to take half of this number in front of the x, so we're going to write plus 4. But we want the x squared, we want the 8x, but when we square this bracket out, it will also give us a plus 16, which we need to take away. and then we can add 19 from the left hand side. If we now collect these numbers together, we get our completed square form. Part B, we need to show that the equation has no real roots. So if we consider, in part B, if we consider x plus 4 squared, because it's a squared number, it must always be larger or equal to 0. So when we add 3 on both sides, the expression x plus 4 squared plus 3 is always bigger or equal to 3. So we're saying x plus 4 squared plus 3 can never reach 0. But x plus 4 squared plus 3 we showed in part A was the quadratic from the question. So this is always larger or equal to 3, and so it's never 0, so it never has real roots. Part C, we need to sketch this graph, stating any parts where the graph crosses axes and where the minimum point is the vertex of the graph. If we look again at the completed square form, we can see, like in part B, the right hand side, the smallest value y can be is 3, because the squared part, x plus 4 squared, the smallest value that can take is 0. So the smallest value the whole of the right hand side can be is 3. This is going to happen, this squared part is going to be 0 when x is minus 4. So this is where the vertex is, the slowest part of the graph. The vertex is at minus 4, 3. We already know that it's not going to touch the x-axis since the quadratic has no real roots, but we're going to find out where the quadratic crosses the y-axis. The y-axis is where x is 0. So we need to put x is 0 in the quadratic, and we get the value 19. So the y-intercept is 0, 19. Now we can sketch the graph. Axes, we need a general quadratic shape that doesn't touch the x-axis. We can label the vertex minus 4, 3 and label y-axis 19. Finally, part D. We need to look at the transformation which mapped the quadratic y equals x squared onto our given quadratic. Again, we're going to look at the completed squared form. If we take the 3 on the left hand side, we can see, if we compare this to y equals x squared, then if we take x becomes x plus 4, or if we write this as x take away minus 4, and y maps to y minus 3, we can go from the first quadratic to the second, the one that we want. So it's a translation, and the vector is minus 4, 3. I'm going to leave you with the key points from this section.